Our next speaker comes from France, but he says that his house is just 10 meters from the Swiss border. A developer advocate with 15 years plus experience consulting for many different customers in a wide range of contexts, such as telecoms, banking, insurances, large retail, and public sector. He will deliver a speech on chopping the monolith. So please welcome on stage Nicolas Frankel.
Thanks a lot. Hey, can you hear me with the mic? Yes, now you can hear me with the mic. I just need like last minutes for the presentation and it should be ready here. So I understand that I'm the only person standing between you and the lunch, which is never a very comfortable place, so I will try to be straight to the point, funny, well, everything. So if I don't get it, sorry. Nobody cares about me, so that's good. I do this talk in a couple of countries. Here, I assume that's fine, but if you are easily offended, please leave. Because, yeah, you can leave. Well, Victor, you are not easily offended. Because, yeah, it might hurt some of your beliefs, and, yeah, it might offend you. So, are you okay? Good. Right now, we are in a very sad state, I believe. And the sad state is if you are doing microservices, you are a good engineer. If you are not doing microservices, you are a bad engineer. Who here is doing microservices? Come on. Half the room? Okay. So I guess you are the good engineers. The other are not that good. Just so we are clear, I won't repeat it to you, but you can read the slides. This is not my definition. This is a definition of Martin Fowler. I will use Martin Fowler a lot, so even if you disagree with me, well, you cannot disagree with Martin. Well, you can obviously, but, well, nobody cares anyway. So now that it's done, Martin Fowler, in this same article, I believe, described the properties of microservice architecture. And I believe that in general, and I will try if it works here, yes, like here, everybody agrees that if you are doing microservices, you are doing componentization via services, and so on and so forth, until we reach the last line. In general, that's the biggest problem. So who here, among microservices developers, is organized around products and not projects? 5 hands, 6 hands, 7 hands, 8 hands. Ah, I don't see people in the back. So we had about half the room. Now we have got like perhaps 10% of the room. So it depends a lot on what you define. And the difference, the biggest difference between a product and a project is a project has an end date, and a product, well, normally should have a recurring budget. So until somebody says stop. And I remember at the beginning of the microservices trend, everybody was very keen on like talking about Conway's law. Conway's law is the idea that in order to get an architecture, you should have the organization targeted at this architecture. This is Conway's. Like, I met him. I was super happy. Actually, he did a talk, and the talk was not that good. But anyway, it still stands true. And in general, organization, classical standard organization, are organized around like teams like this. And guess what? It's the 3-tier architecture. And now, if you want to have microservices, the idea is you should have dedicated autonomous teams. Now, who is organized like this on the right? half of the people from before. So that makes it down to 5%. And the poster child for like microservices and self-organized team is Amazon. In Amazon, they describe it very nicely. Hey, we have self-autonomous 2 pizzas team. Of course, the 2 pizzas team depends on the country, depends on your teammates, but it's a rough estimate, right? And you mentioned that among the audience, there were 5% of people organized like that. So if you do microservices, it will be a failure. I can already tell you the end, it will be a failure. You will have none of the benefits and all of the problems. So the idea, of course, is to say, oh, it's easy. We just need to be organized like this. Right? It's easy. Now, who can drive an organization change from this structure to this structure? Nobody? Well, he looks like a middle manager. So middle managers can drive the change. And the problem is that here, to manage this group of people, there is a middle manager. Here, middle manager. Here, middle manager. Now, can you show me, please, where are the middle managers here? They are self-autonomous. They don't need anybody. So the only people who can drive the change in your organization are the people who will be made irrelevant in the new organization. So I don't know about you, but I don't know many people who will say, oh, I will make myself useless. And that's the biggest problem. The biggest problem is we are tech people. We are not managers. We are not CEOs. We are not even CTOs. Well, perhaps there is one or two here. But if you are addressing this problem at the tech level, it won't work. This is how it works right now. You have a senior architect or even a junior architect. He reads about microservices in a review and says, wow, that looks super cool. Well, we can deploy much faster. And then they try to implement it. And of course, because, as I mentioned, they don't have the right organization, it's a massive failure. But then they run away. And they have put microservices on their resume. Who is familiar with the story? Okay. And that's the problem. The problem is we are addressing it from a technical point of view. We are completely oblivious to the organizational aspects. And if you forget those aspects, it won't work. So why are people doing microservices? Martin Fowler cites 3 main benefits: module boundaries, independent deployment, and technology diversity. So let's see each in turn to see if there is a reason behind it to do microservices for this reason. So first, module boundaries. That's for sure, if you are doing microservices, you will have strong module boundaries. Just as if you want to learn to write with your left hand, you can cut your right hand. It will work, that's for sure. But I believe there are other alternatives that are less painful and more effective. In Java, you have Java modules. You can have like static analyzer that check the architecture. I have recently written about a Spring monolith. If you are in the Java ecosystem, you use Spring. There are many, many different ways to enforce module boundaries. So it's not the right reason. If you are doing microservices for this reason, it's the wrong reason. It's a good side effect, but it's not the right reason. Technology diversity. Everybody loves diversity. So it's good, right? If you are a developer, you love, I don't know, Clojure, and you are in the Java shop, you can bring your Clojure love. You create a new project with Clojure. And it's your own project, your own microservice. Everybody is happy, right? Well, until you leave and your colleague need to handle this Clojure mess. I try to learn Clojure. I will quit if you make me maintain Clojure code. Some people love it. That's fine. I don't. And so the fact that everybody is able to code in their own language, the language that they love, is not a great idea. I mean, if you are a Java shop, it's really hard to hire good Java developers. Imagine if you have to hire a .NET developer. It will be a mess. So from an organizational standpoint, having diversity in your tech stack is really crazy. We have been trying to limit the architectural landscape in our organizations for ages, and then you say, hey, do microservices, and then let your developers be happy. Yeah, developers be happy and the organization dying. Not great either. So perhaps the reason is deployment time. So I assume that you are familiar with DevOps, and there is this golden metrics like lead time. So here is a very simple project. I will do it like this. Specification, implementation, deployment. Specification, in general, is outside our scope. We need business analysts, we need business, we need to communicate with people. We cannot stand on our computer, so it's outside of our scope. What we are responsible and we have leverage on in general is implementation and deployment. And implementation time and deployment time is lead time. This is what we want to make short because we want to deploy as fast as possible. And guess what? That problem is not new. So how did it work in the good old days? I see there are a lot of young people, but a couple of not so young people. So I will tell you for the young people how it worked, and for the not so young people, perhaps remind them how bad it was before. So before there was, again, the monolith. The monolith is bad, really bad. And in order to deploy, we had to test everything. And because the monolith is huge, we had to test everything, and it took a long time. So we couldn't deploy fast. So we set an arbitrary number of times, let's say 4 times a year, where it was possible to deploy. And there was a deadline. And so you had to implement and test and everything until this date. Then you created the monolith, and then you had another team of testers who tested the whole stuff. And after that deadline, you couldn't ship anymore. So basically, if you didn't ship at this release train, you need to wait 3 months. Guess what? The business was not happy to wait for 3 months. So there was a lot of pressure. Who remember those times? Oh, young people also raising their hands. Makes me a bit sad, but that's fine. So there was one rule. You couldn't ship after the release train. But of course, if it was a critical bug, you needed to ship. So guess what happened? Well, your code was ready at the time it was needed, and you shipped buggy code anyway, and then after the release train, you could ship the fixes at your own pace. Was it good for the organization? Probably not, but people adapt to the stupid rules. And so we adapted. And that's how it worked. So as I mentioned, it's not possible to release often and to test everything. But let me tell you something. People will tell you, hey, no, when you release a microservice, you just test the microservice. That's completely crazy. It's like if you release a monolith and you only change a little bit, you only test a little bit. There is as much risk when you deploy a single microservice without testing everything as when you deploy a monolith and not test everything. There is no more guarantee of bugs. Yes, I know about contracts and crap. So the problem is actually very easy. If you have been working on an app for a couple of months, or even more so in a couple of years, you notice, you realize that some parts of the app are changing all the time or arbitrarily, and some parts of the code are very stable. They nearly never change. And so the idea is, okay, those parts are the parts that we want to deploy frequently. The stable parts, we don't care about them. And there are reasons for that. Perhaps the business wants this part to change for whatever reason, or there is a law changing regularly, whatever. And again, in the good old times, we had something called rule engines. Who knows about rules engines? Oh, not that many people. Interesting. So the idea of a rules engine was to tackle this problem, because again, this is not a new problem. You have something that is changing very rapidly and that people want to deploy quickly, but you cannot handle the release train. You cannot wait for 3 months. So the idea is you have a piece of code that can be changed directly in production by the business, under the responsibility of the business. If they want it, they don't need to go through IT. They can directly change it. Sounds like the solution for our problem, right? Well, my experience with rules engine is not direct, but once I had a project with an architect who I knew, and the customer wanted a rules engine because they knew that, well, they wanted to have changes without going through IT, without waiting for 3 months. And so I asked him, hey, like, can you show me a rule? There was a single rule. And the thing is, well, actually no business user would have been able to, like, change the rule because it read like real codes. And then no developer without understanding of the business would have been able to change the codes because, well, it was, if you didn't know the business, it was impossible. So it's not the best solution ever, but it's a solution. And so the idea is, whatever the solution, we can isolate this changing part and move it to a rule engine, a serverless function, a microservice, whatever, and keep the rest of the monolith. And I read the book about microservices from Chris Richardson. And to be honest, I didn't finish it. And it's a really, really good book. It addresses all the problems from the technical side. And in one of his chapters, he tells about the strangler pattern. So the strangler pattern is a pattern which was first described by Martin Fowler, again him, and it says that if you want to like migrate part of your application to rewrite it in another way, you should like first like isolate it under an interface, and then you can change the parts bit by bit until everything has been replaced and you can remove the interface. And this is how it describes. You can do the same at the architectural level. So you start with a monolith, and then you chop one part by one part until, well, the monolith is no more. And if you are into microservices, that's the end target. That's your ideal. That's your paradise, your Eden. And I'm saying that's probably where you will fail. Whereas here, you can have the sweet spot between keeping your organization as it is and changing the parts that you need to change very quickly. It can be a single service, it can be 2 services, that's not important. Again, it can be any implementation you would like. And in the web application, we can use it through an API gateway. So for example, we can have like here the monolith, and in general, you have an API gateway in front or a reverse proxy. And every time you make a request, you go through an API gateway. But if you deploy the API gateway and then you just change the configuration, you can direct a request to whatever you want. And you keep the monolith in place. You don't need to redeploy it. So here is a simple use case. I've worked in e-commerce. I love e-commerce because it's very complex, but still all people understand the problem. I worked on the platform where basically there was like pricing rules, but every time you added some stuff to the pricing rule, business wanted something that was not out of the box. You had to write another custom pricing rule. That's the problem of pricing. The business is very creative. And so basically, once you have a no shipping cost, get 2 for free or whatever, business wants something else. So this is, for example, this could be a serverless function, pricing, compute the pricing, or a rule in a rule engine. So we want this price to be very flexible, and we want to deploy it very, very quickly, as much as we want. So here I have a little demo, and I will switch to my IDE. So I've created an application. The application is a Kotlin application. It's like a very simple e-commerce application. What I will do first, I will start the architecture. And because well, dope, it doesn't work that well. Okay, up. Then I can describe what it does. It's a Kotlin Spring Boot application. And the idea is I have here, when I go on the checkout page, and I will show you afterwards how it works, I get the cart, and I want to compute the price of the cart. So what I'm doing is I'm here getting the pricing, and I don't, yes, here. I call the pricing, and right now, the pricing is an internal function. So I don't expose it, because that's my pricing. What I'm doing now is I have here my Docker Compose file. The fonts. The fonts. Ah, sorry. Nobody tells me. Better? Come on, I'm in Greece. I need feedback. You can tell me everything. So here first I have the API gateway. I'm using Apache API 6 because I'm working on the project, but you can use whatever you want. We are storing the configuration in etcd, so it's a requirement. Then I have the application, chop, and I have the database, so nothing really crazy. And I will go through the API gateway, so I direct every call to the chop. So I just run this, and because Apache API 6 is an API gateway, it's managed by APIs. So here I created a new route that says everything directed to the chop. So now if I go on my application and I do localhost 9080, I have my e-commerce shop. I can add stuff to the cart. Here you see version 1.2. I can go to the cart, and at the moment, I will just go to the network stuff. I will reload, and at the moment, I have just the response. The response gives everything in one go. It gives me the cart, and it gives me the price. So my next step is just to change and to make the pricing a route. So I keep the code as it is. And I do like this. I still have the pricing stuff. I've kept everything. So at the moment, the pricing is just like summing the price because I'm super lazy. But I've created a route, a dedicated route to have the pricing. So now I can deploy the new version with the pricing that is exposed. So Docker Compose, up, chop, shop. And now it's the fun part, where I need to find here that it has started. And since it's a like JVM application, it might take a bit of time. In general, it's 20 seconds. So cheers. Nope, please. It's not the right time for the demo to fail because I tried yesterday, I tried this morning. And of course, there is an issue. Let's try, but I'm afraid that worst case, I will stop and I will. No, it's not Ethernet. It's yes, it doesn't work. Okay, I will just go down everything and hope that I have enough memory. It's not a memory problem. Sorry about that. That's the good. It's super slow. Uh-oh. Uh-oh. Let me quit stuff. Quit. Quit. It's really bad. It's not the network, it's my machine. Down and 1, 2, 3, 4. The problem is that even the keyboard is not responsive. Okay, what can I quit? Perhaps I can quit everything. I want to keep my tabs. I can quit this. I can quit this. Yes. So sorry about this. Normally it should have just reloaded the right stuff. I need to like redo the routes again. So this is the same route. So imagine everything went fine from the first time. Okay, now I go on my shop, I add stuff to my cart, I remove everything, then I go on cart. So now it's version 1.3. And now I have two routes. So the first route gets the cart, the second price computes the price from the cart. And you can see the origin is monolith. And now I won't deploy anything. I will just, like, as I mentioned, I will go to the next step, and I will create a new dedicated specific route only for the pricing. And this pricing here, I send it to an Azure function. It could be anything, but Azure is already like integrated in Apache API 6, so I have a plugin for it. And now, if I refresh, it will take more time. You see, it's a bit slow, but the response is from Azure. Because here, I created the same function. I copy-pasted it. It was in Kotlin. I copy-pasted it in JavaScript. And I just chopped the port that I wanted. And I didn't deploy. So now, every time the pricing changes, you can do the change in Azure. Again, Azure is just an example. You can do that in Google Cloud, in like any rules engine. Here is the stuff that I copy-pasted. So now there is dead code in my monolith, but I can remove it at the next deployment. I can keep it here. It just won't be used. And folks, that's all. You can follow me on Twitter. I have created a Mastodon. I have a social experiment. If you're on Mastodon, please, I would like you to follow me there, if only for a small time, because I want to check how many people are on Mastodon. If you're interested about the codes, here you have the GitHub repo. Here. You have the GitHub repo. You have the blog posts, and if I got you interested in Apache API 6, you are welcome. And now you can join me on stage and ask me questions.
Yeah. So thank you very much.
2 seconds. Keep the last slide, please.
So basically, now you discouraged everyone in the audience to leave their companies.
You can vote with your feet, obviously. And now, do we have questions? Because
yes,
it's lunchtime.
We do.
Yeah. You are not hungry.
And mine will be, okay, so there is no, you cannot save those that early adopted the microservices without an organizationally change.
You are doomed, yes.
Okay.
Yeah, I mean, sorry, I'm straightforward. We had dinner yesterday. If you adopt microservices for the wrong reason, with the wrong organization, you are not an engineer. I'm sorry for that. And probably you are not the one who took the decision, but you need to follow somebody who is not an engineer. And I'm a firm believer in Darwinism. You shouldn't follow people who are not engineers if you are an engineer. So yes, you should quit the company.
Okay.
Or make the CTO fired. But in general, it's easier to quit.
Okay. So we have a couple of questions for you. In several organizational cross-functional teams still have middle managers, engineer managers. Do you believe that these roles are now redundant? If yes, why companies still maintain these roles?
So I cannot talk for companies that I don't work for, but in general, I've worked like more than 20 years in IT. I always said, if my manager is there to approve my vacation requests, to every year be the proxy for my pay raise, and to do some reporting, then probably they are not useful. And even more so if they are paid more than me. So it's not my position to judge in this company. I don't know. Perhaps they are doing good stuff. I have had good managers, probably less than a number of fingers on one hand. And they were really good. So if you have a good manager, please, whatever the organization, follow them wherever they go. In general, it doesn't work. But anyway, so again, I don't know this company, but if your manager does only those three things, yeah, redundant, no value.
Okay, and we have another one. It says Java champion Vlad Mihalia posted on Reddit, Shopify monolith served 1.25 million requests per second during Black Friday. Consider the fact that spin-ups of functions as a service take a significant amount of time, not to mention money. How do you think Shopify will achieve the same result if they decide to chop the monolith?
Alexios, you didn't listen to my talk. You didn't. Because you are talking about scaling. Where did I mention scaling in my talk? The problem is not about scaling. Again, it's a problem of engineering. What problems do you have? Problems you have is you have too many engineers working on the same code base. You need microservices. That's the only reason. Shopify is doing engineering. They can handle their scaling with a monolith. They don't need to deploy often. They can work on the same code base or whatever. Why would they need to change to serverless? It's really, no, you're asking a good question. I'm just like joking. The thing is, our industry is supposed to be full of smart people. We are supposed to be smart engineers. And most of the time, I don't see any engineering. I see people like saying, oh, it's shiny, I want it, it's cool, I want it on my resume. Hey, can I get it? I prefer boring stuff. Stuff that works. Yes, you won't have it on your resume, but if I should hire you, it's not because you have a lot of keywords on your resume, it's because you are doing proper engineering. Proper engineering is you have, like if you are young, junior developer, you have like this many tools. If you are senior, you have many tools. You have a problem, you pick the right tool for the problem that you have. That's engineering. The rest is just time wasted. The rest is just trendy. For that, go on YouTube. But if you want to do proper engineering, do proper engineering. Right now, what we are doing is we see a company like Google or Amazon, and we say, oh, they are doing like this. And we don't care about the problem. They are doing like this, they are big, they are successful. If we do the same, we will be successful. That's called cargo culting. You know about cargo culting? So there is this story that in the Second World War, there were some islands in the Pacific that were populated by people who never have met anybody else. Then the American and Japanese came. Well, there was a war, and they came with their planes, and planes contained people, and people brought food. And they thought, wow, if we could attract this kind of stuff, they couldn't say it was plane, we could get more food. How do we attract this stuff? Oh, let's build a radio tower in bamboo. Because they understood that there was a radio tower that attracted the planes. Well, they didn't attract any plane. So if you just copy the form without understanding how it works and the problem, you will never attract any plane. If you copy microservices, agile, whatever, and you don't have the problem to solve, you don't have the same context, it's not proper engineering. Sorry for this sad fact.
But sometimes it's also a matter of replacing a legacy application, where you don't have the opportunity to say, okay, I'm going to go gradually, and use the very well expressed 80-20 rule, where it says, 80% of my changes are on 20% of my code. So in that case,
why would you need to replace it with microservices?
I'm not saying you will, but you will be faced with a decision. And if you go to the cloud, then microservices fits in well as a model in that sense. Well, at least it's broadly...
it's perceived as well. The vendors are telling you, yeah, do that. Come, get me money.
You also have a bigger pool of programmers that know how to program that. That's also important.
I don't want pool of programmers, I want pool of engineers. I don't want 20 people who say microservices. I want 2 people who say, okay, this is the right tool for the job.
Okay.
But okay, if you are a manager, you want as many developers as possible, because then you can put on the resume, I want 20, I manage 20 developers.
I'm not putting that
no,
as
but
an
I
issue,
know how it works. Huh?
Yeah, but well, I mean, people learn stuff. They choose to learn microservice-oriented.
Then perhaps they are not a good fit for you.
Okay, I hear you. I respect that answer. Yeah, definitely. So we appreciate.
Yeah, thank you.
So sorry,
very
just
much.
before lunch,
Thank
you had
Nicolas.
a fact check. I hope.
But it was a very interesting perspective, I must say. I mean,
Yeah.
I really enjoyed it.
Yeah.
Thanks.
Thank you so much.
Thanks
I
a
hope
lot.
our audience enjoyed it also.
This
This is for you, a gift. We appreciate coming here to our event. Thank you so much.
Thanks a lot.
Really had a great time interacting with you.